Hello everyone, in this video lesson we are going to talk about inferential statistics. Let's get started. I do hope that you still remember what inferential statistics is. Earlier in this course, we talked about two different types of statistics based on its functions, right? The first one is descriptive statistics that you have learned before the midterm. And then the second one is inferential statistics. So what is inferential statistics? From the name or from the term, you know that the function is to infer, right? Okay, so when we use inferential statistics, we select a sample from a defined population and we study that sample in order to draw conclusions and make inferences or infer about the population. In other words, we would like to estimate the population parameters. You still remember what parameter is, right? The rationale or the assumption behind the use of inferential statistics is that since the sample represents the population, so you know that sample is a representative part of the population. What is true for the sample is probably true for the population from which the sample was selected or was taken. Yeah. Okay, so when we assume that something is true for a sample that we investigate or that we research on, we assume also that it is true for the population from which the sample is taken or selected. Okay, these concepts of inferential statistics are taken from this book, Rayfield 2011, the main reference that we use in this course. Yeah, please read the book again to further understand these concepts of inferential statistics. All right. Okay, so here is a visual illustration of the two types of statistics that we have learned. The first one is descriptive statistics, whose function is to describe data. So you use percentage, you use a frequency, you use central tendency, you use measures of spread or dispersion to describe data. We call those as descriptive statistics. And then the one that we are discussing today is inferential statistics, when we study a sample of the same data to estimate the population. Okay, going further on, the common inferential statistics that we use in our field, namely applied linguistics. First, we have the inferential statistics to assess relationships. For instance, here, correlation and regression. And then the inferential statistics to compare means or mean scores. We have t-test, we have ANOVA or analysis of variance. And for more complex designs, we have ANCOVA or analysis of covariance and MANOVA or multivariate analysis of variance. Yeah. And then when you have non-normal distribution or the skewed distribution and small sample size, we have what we call the non-parametric tests. Yeah. Okay, so here you can see the examples, especially when we would like to compare means, the examples of common inferential statistics we use to compare means. The ones that we will focus on in this course are different types of t-test. Here you have three. one sample t-test, two sample t-test, and paired sample t-test, and then one-way ANOVA. Yeah, we will not really focus on one sample z-test. Yeah, instead we will use t-test. Yeah, okay, and if you take a look at this column, the assumption column, all of these assume for normal distribution. Yeah. So in other words, they are parametric tests. Yeah. What about the not normal distribution, the skewed distribution, or the small sample size? Can we still do some inferential statistical procedures? Yes, we can. But instead of using the parametric tests like t-test and ANOVA, we will use what we call the non-parametric test. For each parametric test here, for different designs as well, the correlational designs and the cause and effect designs, we have an equivalence of the non-parametric test here. Yeah, okay. So we will learn about this also further later. All right, so if you still remember, in one of our first meetings, we talk about one of the functions of inferential statistics, namely to test the hypothesis. Okay, so what is a hypothesis? I do believe that you have learned about hypothesis in your research, in your quantitative research course. Yeah. So a hypothesis is a temporary scientific assumption. Okay. Although not all quantitative research designs require a formulation of hypothesis, but since we are talking about inferential statistics, we have to talk about those that require hypothesis formulation. Yeah. So that's why you have to understand first the concepts of hypothesis. Yeah. So a hypothesis again is our temporary scientific assumption. And then it should always explain what we expect to happen. So our expected results, in other words. And then it should be clear and understandable. It should be testable, or we should be able to test it by using existing inferential statistical procedures. It should be measurable. And when you have cause and effect design, it should contain the independent and dependent variables. Yeah, I do hope that you have learned about this as well in your quantitative research class. Yeah, independent and dependent variables. Okay, so further on, we have two more concepts of hypothesis, namely the nil hypothesis, or HO, and the alternative hypothesis, or HA. So the nil hypothesis, from the name, you know that it predicts that there will be no nil, zero, no relationship between variables, or no difference between groups. And if there's a difference, the difference may be attributed or may be explained by chance. It's not by statistics. Yeah. All right. We have another type which is called alternative hypothesis, or oftentimes it is called or referred to as the research hypothesis, our hypothesis as the researcher. This alternative hypothesis guides our research and gives direction to the design of our study or research. It predicts that there will be some relationship between variables, or there will be differences between means or between groups. Yeah. So the nil hypothesis is basically the negation of our research hypothesis or our alternative hypothesis. So you know that you have to formulate your hypothesis in terms of statements, yeah, to indicate whether there is a relationship between variables or whether there is a difference between groups or mean scores. And then you have to formulate the hypothesis as well statistically. Yeah, so first in statement and then statistically like this. All right, so you see, when we formulate the hypothesis statistically, we use the HO or the null hypothesis as the indicator to test our hypothesis. Yeah, and then each formulation will depend on the design of your study, whether it is correlational or the cause and effect design. And also it will depend on how many groups or how many sets of mean scores you are comparing. Yeah, whether it is one sample t-test, when you compare the mean score of the sample with the mean score of the population, or whether you have two independent samples to compare, or whether you have two matched or paired samples to compare, or whether you have more than two groups to compare. Yeah, we will learn about this further when we do the practice later. Yeah, when we deal with the data set and the formula. Yeah. All right. When we talk about estimation in statistics, we also talk about how statistically confident we are. So we have what we call the levels of confidence, level of confidence. There are some levels of confidence, but here I only show you the most commonly used ones. Yeah, there is 90%, 95%, 99%. What does it mean? So when we have a 90% level of confidence, so we are confident that 90% of the results later that we calculate will be based on statistics, yeah, based on statistical prediction. And there will be 10% of the chance, okay, of the error there. Error here does not refer to mistakes. Yeah, it's not about calculation mistakes or things like that. But error here refers to other factors, including or mostly is related to sampling error. Yeah. Okay. So 10% room for error, 90% confident. And then for 95%, it means that we are 95% confident statistically. And then there are 5% chances of error. And also for 99%, we have 1% of chance for error. Yeah. Okay, so that's why in relation to levels of confidence, we have what we call the levels of significance or the alpha level. Yeah, see, they correspond to each other here. Yeah, when we have 90% here, you have 10%, right? So 0.1, and then when you have 95%, you have 5% or 0.05. And then when you have 99%, you have 1% or 0.01 here as the level of significance. Okay, and then we will have another term. We call it the probability value or p-value. Yeah, they are all related to each other. And we are going to talk about those three terms, levels of confidence, levels of significance, and a p-value later when we deal with the practice with the data set. Yeah, okay. And this is just an illustration. So normally in our field, we use 95% level of confidence. So that's why our level of significance is 0.05. 0.05 or 0.05. Yeah. So when we would like to reject our nil hypothesis, yeah. So when we test a hypothesis, what we would like to do is we either reject or accept the nil hypothesis. Yeah. Ideally, you would like to reject your nil hypothesis. You would like to accept your alternative hypothesis, right? So we, based on the inferential statistics that we used, we would like to have a probability value which is smaller than the level of significance. Okay, going back again to the previous, to the previous slide. Okay, so when your level of confidence is 95%, your level of significance is 0.05, right? 0.05. Your probability value, in order to be able to reject your nil hypothesis and accept your alternative or researcher hypothesis, your research hypothesis, should be smaller than this. So when you calculate your p-value later, when it's smaller than your level of significance, that means that you can reject your nil hypothesis and accept your research hypothesis. Yeah, the ideal condition. All right, so we will learn, if you're still confused about this, it's a bit complicated, I know, but we will see later when we have the data set, then you will understand better how to use all these difficult, complicated concepts into practice. Yeah, no worries, don't worry. Okay, so hypothesis testing. Okay, so just like what I mentioned earlier, we would like to reject our nil hypothesis and accept our alternative hypothesis, though it might not always be the case, but we would like that to happen. Yeah. So for each hypothesis formulation, we have what we call the hypothesis testing, and we set the criteria for the HO, or the nil hypothesis rejection, the criteria to reject the nil hypothesis. Okay, some examples and rule of thumbs are these. So this is for correlation. Yeah, when you have correlational study and you use Pearson correlation parametric test, you are going to calculate the R here. The symbol is R for Pearson correlation. Yeah, the R that we calculate from our data should be, the value should be higher than the standard, the critical R value. We call it the critical R. Then we reject the nil hypothesis. The same goes to t-test. When we use t-test, we calculate the t value, and our t value should be bigger than the critical t value or the t table. Then we can reject the nil hypothesis. Also, when we use ANOVA, analysis of variance, or F-test, the F value that we calculated should be bigger than the critical F value, then we reject the nil hypothesis. Our p-value, remember again, in the previous slide, the probability value should be smaller than the level of significance, should be smaller than 0.1 or 0.05 or 0.01. Yeah. Okay, so there are basically two rules of thumbs. The first one is related to the value of different tests, different inferential statistical tests that we use. Can be R for correlation, or T for t-test, and F for ANOVA, MANOVA. And then the second one, the second indicator is related to the p-value. Yeah, okay, so it might be a little bit intriguing and confusing at the moment. This sounds too theoretical, doesn't it? But later, when we already deal with the data set, hopefully you can understand these concepts better. Yeah, keep in mind all these concepts first, and then later when we already use the real data set, then you know, okay, this is what it means by rejecting null hypothesis, and this is what it means by R calculated, and this is what it means by R value, and then how we compare the values in order to get to the conclusion whether we reject or whether we accept the null hypothesis. Yeah. Okay. So let's go on. Yeah, when our hypothesis is supported, when our alternative hypothesis is supported, we'll be very happy, of course. Yeah, that means that statistically, you can test that your assumption is somewhat accepted. Yeah. Okay. But we have to be careful though. We have to be careful though. Sometimes there can be some errors when we test our hypothesis, yeah, by using the hypothesis testing. What kind of errors and what are the possibilities? Okay, there are two types of errors. There are two types of errors. The first one is what we call the type 1 error or false positive. And then the second one is what we call the type 2 error or the false negative. Okay, what does it mean? This is related to the acceptance and rejection of null hypothesis. Yeah. Okay, when you have a type 1 error or the false positive, okay, something like this, yeah. So the guy here, the man here is not pregnant, definitely not pregnant, can't be pregnant, right? But because there's an error in the analysis, in the statistics, in the statistical logic, so here the doctor has drawn what we call the type 1 error conclusion. Yeah. So he concluded that the man, based on the result of the test, was pregnant, positive. Yeah. So in other words, actually, you have to accept the null hypothesis that the man is not pregnant. So the null hypothesis is the man is not pregnant. The alternative hypothesis is the man is pregnant. But because there is something wrong with the statistical procedure, so the result shows you that, okay, the man is pregnant. So you have to reject your null hypothesis and accept your alternative hypothesis, right? Okay. Yeah. So that's the type 1 error. So supposed to be no relationship or no difference, but you accept it the other way around. Yeah. The type 2 error or the false negative is the contrary. Yeah. So actually, you have to reject your null hypothesis. You have to reject your null hypothesis, but you accept it. Yeah, you accept it. So the null hypothesis is the lady is not pregnant, and the alternative hypothesis is the lady is pregnant. But because of the procedure, the error in the procedure, in the statistical procedure, the result shows that you should accept the null hypothesis while you shouldn't. Yeah. Okay. Well, if you are following the news about COVID-19, about the rapid test, okay, maybe you have seen this term or these two terms a lot, the false positive, false negative. Yeah, but rapid test is claimed to be given a lot of false negative, if I'm not mistaken. Yeah, so it's not reliable because it gives a lot of false negative, which means that the rapid test shows that you're not contracting the virus while you are actually contracting the virus. Yeah, when you use swab test and then okay, PCR test, and then you're actually positive with the virus. Okay, so neither of these types of errors is good. Yeah, both of them are not good, but in terms of severeness, which one is more severe? Of course, you know that type 2 error might be a little bit more dangerous. Yeah, okay, when you talk about life and death situation, so type 2 error, false negative, is somewhat more detrimental, more these advantages than the type 1 error. But you shouldn't really perform either type 1 error or type 2 error. So that's why you should be really, really careful when you use inferential statistics. Yeah. Okay. So what will be the possible cause for type 1 error? Well, mostly when we are dealing with type 1 error or false positive, it's related to the sampling error as well. Yeah. Okay. So the other type of error, the type 2 error, when we talked about type 2 error, this might be related to the levels of confidence. Yeah. When you set the bar too high, for example, 99%, there's a chance that your results won't be significant at 99, but the results can be significant at 95, for example. Okay, yeah. So accuracy for type 2 error as well. Yeah. Okay, but anyway, we have to be very careful when we implement the inferential statistical procedure, so that we will not end up performing either type 1 error or type 2 error. Yeah. Okay. So wrapping up, we have learned about inferential statistics, whose main function is to infer or draw conclusions about the population from the sample, from the data taken from the sample. Yeah. And then we have different types of inferential statistics depending on the designs of the quantitative research that we are dealing with. We have correlational study or design, we have cause and effect or experimental design. Those will require different types of inferential statistics. And also we use inferential statistics to test our hypothesis. So that's why we need to formulate our hypothesis first. And then we choose the correct statistical procedure or the inferential statistical procedure to test our hypothesis. Yeah. Okay, so this is just another statistical meme to end our video lesson for today. Yeah. Okay. So I used to think correlation implied causation. Causation, what does it mean? Causation means cause and effect. Yeah. Then I took a statistics class. No, I don't. Sounds like the class helped. Well, maybe. All right. So I do hope that after this, you will also feel the same. Yeah, that you can differentiate between different types of designs of quantitative research designs and logic, and then also to see which inferential statistics to use for different types of the research designs. Yeah. All right. So after this, please go to the comment section and type your comment summarizing what you have learned from the video and from the slides. And also, if you have questions or further questions about the topics, you may write the questions down as well in your comment. Yeah. Okay. But before we go on with the comment, I would like to explain about your next assignment related to the group video presentation and still about inferential statistics. Yeah. Okay, let me share the screen. All right, so your next assignment after this week, it's a group work. What you need to do, there are two different tasks. The first task is to read the materials and make a summary. Okay, I would like you to form 4 groups. Yeah, and each group has to choose one of these topics. The first one is correlation and regression. The second one is t-test. The third one is ANOVA or analysis of variance. And the fourth one is non-parametric statistics. Okay, so again, first one is correlation and regression. The second one is t-test. The third one is ANOVA. And the fourth one is non-parametric statistics. Yeah. And then what do you have to do? Please summarize the important points, including the basic concepts, definitions, functions, types, formula, hypothesis formulation, and hypothesis testing. You can refer back to the discussion that we had, and also to the materials that we have discussed in this video lesson. Yeah. And then the examples of application used in which type of quantitative research. For example, t-test here, in which type of quantitative research do we use t-test? And then the examples of research in TEFL or applied linguistics. Yeah, so you might go to some databases or some journals to check on the examples of the research which use these inferential statistical procedures. Yeah. And then write the summary in PowerPoint slides. Yeah. The second task is your group video presentation. Please prepare a video presentation based on the PowerPoint slides that your group have prepared for task 1 previously. Yeah. The duration of the presentation will be around 20 to 25 minutes, so approximately 20 to 25 minutes. Yeah. The presentation format, since this is a pandemic situation, very specific situation. Yeah. I do not advise you to come together, but please do the presentation one by one. Yeah, because this is a pandemic situation, so please do an individual presentation of the member and then combine the individual presentation. Yeah, so each member of the group will record him or herself and then later compile the individual presentations as one video presentation. Yeah. Okay. So that means each member of the group should take parts in the presentation. And the language of the presentation is, of course, English. External references are allowed. Yeah. So, of course, this is the main reference, but you can still use other external references, provided that these external references are from credible resources. Yeah, and do not forget to list your external references in your presentation materials. Yeah, so later your friends can check the references as well if they would like to see further explanation. And then each group has to post their video presentation on YouTube as scheduled. So you see here, we have the schedule for each group, yeah? And the links of the video presentation together with the PowerPoint slides should be posted in our WhatsApp group at least 10 minutes before the assigned schedule, yeah? So the schedule here is actually the schedule for your regular class, yeah? Okay, and then for the audience, for the students who are not presenting on that particular date, you should prepare one question and write down your question on the comment section of the YouTube video presentation posted by the presenting groups. Yeah? At the latest, of course, it has to be on the schedule as well, but at the latest, one day after the videos are posted. And then the presenting group has to answer or reply or respond to each questions or all the questions posted by the audience in their video presentation post. Yeah. I will also drop by to respond to the questions. Yeah. And I might also ask some questions for you. Okay. And if you post the question, don't forget to mention your name, class, and group number in the comment. Yeah. So the group will be able to identify which is which or who is who. Yeah. All right. So that's about your video presentation. Yeah. If you have further questions, you can ask in the WhatsApp group or send me an email before the scheduled date for your group presentation. Okay, so that's all for now. Don't forget to write down your comments or your summary and questions about what you have learned from this video lesson down there on the comment section. Yeah. See you.